This is the Empower Podcast, released November 28th, 2021. Episode 568, sponsored by Mauser Electronics. YouTube to Consulting with Florin of Voltlog. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
My name is Florin, but most people know me as Voltlog from the Voltlog YouTube channel.
Hey, Florin, how are you?
I'm doing good. And how are you, Chris?
Good. I find that I increasingly have stuff, I point to stuff on my bench and people are like, oh, where'd you find out about that? I was like, well, Voltlog made videos about this. Your YouTube channel and your videos, increasingly you find stuff that I'm like, oh yeah, that's got to be on my bench. So thank you for that.
Yeah, no problem. I like doing that stuff. And I think that's probably one of the main reason that people follow my channel, because I discover interesting stuff that they can learn about it and then later on use it for something.
That's right. Yeah, I think the things that the main one on my bench is the long throw microscope. It's like it's like a webcam almost, but super useful for basically monocular, not binocular, but monocular vision. And then I put it to a small monitor on my bench. You actually put that into a trinocular setup, right? On your bench.
That's a great thing, though, because you can use it in different setups. Like you have the monocular and you have it at a higher distance up your workbench, because I've seen a picture of your setup and that works great for you. For me, it works better on a trinocular microscope. So that's great because we have the flexibility for that kind of camera.
Yeah. It also seems like you kind of find stuff that's like lower cost, usually like AliExpress, Banggood, things like that, and that's always useful too, just because it's a lower risk. It's not necessarily the cheap. It's not like $10, but it's like maybe $100 for a microscope versus looking at something like Dave has, like a Mantis. I'm like, oh, yeah. I'm not paying $3,000 just to try it out. So like, that's a tough sell.
Anyone would love to have a Mantis, but not anyone gets one.
Yeah, that's right.
and so we need the alternatives. Like most people need the alternatives.
I have a running eBay search, and there's like some album, there's like some like CD or album from the 70s that has Mantis in the name. And so like probably like twice a week I get this thing that's like, ooh, new Mantis listing. I'm like, oh, the CD again.
Oh my God. That happens to me as well for various searches.
Yeah. You got to be real specific, but sometimes it's good to have like just the really broad search and do the human filtering, just because you might get someone who like labels it wrong or whatever. It's just you have to put the work in.
And for that reason, you could get like a really low price for a specific item, which would otherwise sell for a lot more.
That's right. Yeah, I used to play drums, and I think I mentioned this on the show before, but I used to have running searches on Craigslist, which is like a classified listing in the US, and I would always spell symbols wrong. So instead of like symbols CYMBALS, I would do like SYMBOLS and like just get people who are terrible at spelling and try and get some cheap equipment off people who can't spell.
It's really clever, man. I never thought about doing that.
Yeah, it's a little more helpful when it's like really available stuff. Like a Mantis scope or microscope is going to be a lot more rare, it feels like.
Yeah.
So you're usually buying this stuff from like a AliExpress or Banggood or stuff, but you are shipping it to Romania where you live. What's it like in Romania? What's the electronics scene like? What's it like getting stuff imported from China equivalent? What's that like?
So I would treat these as two separate subjects. So one of them, importing stuff into Romania, is not as easy as one would think of, like when you compare the experience that you have in other European countries, or even with importing stuff into the US. So first of all, when you import something from outside the European Union into an European Union country, you will have to pay VAT on that. And recently they changed the rule on that, because previously there used to be this rule that anything under 10 or 15 euros wasn't really supposed to be charged. So a lot of these small packages used to go through without being charged VAT. But recently they changed that. So now it doesn't matter which value your package has. It has to be charged with VAT. And because of that, various postal services also started charging this handling fee because they are now collecting that
Oh,
VAT for the
jeez.
government.
Yeah. And just for people that are U.S. centric, VAT is value added tax. Is that right?
Yeah, that's just
Yeah.
a tax that gets added to every product, every purchase.
Yeah. Well, you operate as a business now. Are you allowed to do like the pass through thing? And
It depends. Like it depends on what, because you could be registered with different types of handling of VAT. So the most common way is that you still pay VAT. So there's no,
mm,
but once you go past a certain threshold in your business, you are obligated to switch to collecting and dealing with
oh,
VAT.
got it. Got it. Yeah, that's yeah. I mean, the handling charge too. That I mean, what I did you make a someone made a video about this? I think it might have been you, but it was basically like a lot of the low cost packets. So like something where you
Yeah,
might get like a $5 supply in eBay, like a power supply. It's like that doubles the price and becomes a
yeah,
hassle now.
yeah. Just because of the handling charge, which is a fixed rate, and sometimes that's higher than the actual VAT.
Yeah. Okay.
But then you have also a number of other limitations that might happen for various products. I don't know. Some types of products have these additional import tax on top of VAT, but it depends on the category that that product falls in.
hmm
So I really don't remember any specific examples right now, but in often cases you are charged with an additional import tax.
Got it. All right. So more of a hassle than it used to be, which sucks. But
Yeah, and it's also not just about collecting these taxes. It's also about how slow the process is. Because
oh, right.
yeah, a lot of, at least here in Romania, a lot of this stuff doesn't happen automatically. So I would be happy if the package was delivered next day with an invoice, and
hmm
I'll just have to pay that invoice.
Yep.
But a lot of the times it's not like that. It's a hassle. It's a
Yeah.
lot of emails have to be sent. A lot of
Uh,
documentation needs to be supplied to the like customs authority, and that just takes times and add delays when you're like doing consulting for a client and you have to build a board
right.
and you have to
Right.
build some prototypes. You have to explain to that client that there's a 1 week delay because some authority in your country needs to process that import
right.
until you get it.
Right. I'm walking him through what a capacitor is and an inductor and why I had
Yeah,
to buy these. It's
stuff
like,
like
oh my
that.
god.
Yeah,
Yeah. Oh boy.
so that definitely
Yeah.
adds a layer of complexity and delay to every import I have to do.
Yeah.
But there are
Yeah.
also good stories, like for example Mauser has this system where they collect all of the tax and they file all of the documentation required on their end.
Oh really? Oh
So yeah, I could have like a Mauser order placed Friday evening and have it delivered Monday morning, and that's
wow.
like 6,000 miles away from me. And
That's
that's
pretty cool.
impressive.
Yeah. Yeah. Yeah.
And that's totally because they handle this on like a higher level.
Yeah.
It doesn't have to go through the local authorities here anymore.
That's nice. Yeah. That's great. So then you also said there was like a two-parter there as well.
Yeah.
So then what is Romania like? So is there an electronics scene that locally, stuff like that? How did you get into electronics?
It's a funny story, actually, how I got into electronics. Like, I don't know how it used to be in the U.S., but here when I was a little child, the old cars used to have very basic electronics in them,
Mm.
but
Mm-hmm.
still they have a couple of blinking LEDs or stuff like that. And I was always curious, when I saw those things, and I always wanted to understand how that works, and I wanted to be able to build my own circuit. So I started as a very young kid, tinkering with electronics.
Usually the next line in the story is then I started taking things apart. I'm a little worried. I'm a little worried for the adults in your life at this time. They walk out
Yeah,
to their car being disassembled.
yeah. I mean, I did it all. Like my parents keep telling stories like I used to plug things into the wall sockets and I used to get shocked early on.
Yeah, yeah, yeah.
Yeah, and I did all of that as early as possible. but but then so I started getting some electronics books. Some of the stuff in there was very hard to understand, and
Hmm,
and I,
yeah.
I realized that I need to follow some kind of school education that would help me understand what they're saying in these books, so I can understand those circuits and actually build them and modify them. So then, the obvious followed. I studied, I got my bachelor's degree, and from then I started doing all sorts of projects and even consulting. Like
Yeah.
I'm pretty happy to and lucky to be able to say that, for example, during my bachelor degree, I was able to design this development board based on a microcontroller and actually sell it to the school where I was studying at.
Oh, really? Wow.
Yeah, so not a lot of people get a chance to do something like that. So I was pretty lucky to be able to do that.
And what was on that board?
So the issue was that we had these microcontroller classes in school, but we studied a lot of theoretical stuff. Like we wanted to be able to test the programs that we were thinking about, the algorithms that we were implementing, and we wanted to see how coding for these registers inside the microcontrollers would actually behave on real hardware, and we were missing that in class. So I just built a board that used a PIC32 microcontroller and had lots of peripherals on board, peripherals that are typically fun to play with, like sensors, temperature sensors, accelerometer, an LCD, a serial interface, stuff like that. It would be fun for someone to write code and actually see something happening with that board.
Right. And I think you also remove a lot of the jumper wire aspect that a lot of school programs do, which is, it has value in its own way. But if you're focusing more on the code than the, what hooks to what, then that can really help to move things along and let people go a little deeper on the code side.
Yeah, certainly. But then to answer your other question, what is the electronic scene here in Romania? It's not as good as I would like it to be. I know, for example, that if you want to work in this field, there are a few companies, mainly in the automotive space, that hire people to build electronics. But other than that, I don't think that there is a lot of electronics industry here in Romania. And
Okay.
it was the obvious choice for these big automotive companies like Continental and others to open up shop here in Romania, because there are a lot of talented young people, and it's probably cheaper for them to hire talent here than it is in the west of Europe. But other than that, I don't think we have an electronic scene here in Romania. So that's why a lot of my activity is in the online playground.
Uh-huh. Yeah. Yeah, that's great. And it opens it all up so that you can be in the marketplace
totally.
and offer your services and obviously make great videos. Like that's awesome.
Yeah, totally.
Yeah. Cool. Yeah, I remember Hungary has a decent amount, which is east of Romania. Looking at just like other countries in the area, Poland has, we've had Aunt Micah on. They're up. I forget where they are. Poznan maybe, but they're up in Poland. So like kind of like obviously Eastern Europe, Eastern Europe and stuff like that in general has some electronics, but it seems kind of it's a large area, of course. It almost seems equivalent to the U.S. and like spreading across the Midwest. There's pockets of electronics in different areas, but if you're not in that specific pocket, it's like, okay, well, what is this really going to do for me?
Yeah, exactly. And in the actual city where I live is Constanța, which is near the seaside. It lacks even more in the electronics industry. So I had the choice of either do something in the online space or relocate. And I really like the place where I live. I wouldn't want to move unless it's absolutely necessary.
Yeah. I mean, living by the seaside is pretty nice.
Yeah,
Yeah.
I love it.
Yeah. Yeah. Black Sea. That's cool. That's really cool. I'll have to look at some photos later. That seems like there's like one really interesting looking old building right on the seaside in the Google images. I'm not sure what that is. It looks like
it's the
1800s.
casino, maybe it's called the casino.
Yeah.
Yeah, that's actually renovating right now.
Oh, cool. Okay. Yeah, that's great. All right, I'll add it to the list. Got other places I got to visit. Yeah, that's great.
Actually, Andreas Spies, you know him. You've had him as a guest on Yam Power. He was here. He visited and he liked it very much.
Oh, awesome! You guys get to hang out.
Yeah. It was pretty cool to hang out with the Andreas Spies, the legend.
Yeah. This the Swiss YouTuber.
Yeah.
So let's talk about some of the videos you've been doing. So you mentioned the automotive industry, and I have noticed you've done quite a few videos on like interfacing to a car,
Mm-hmm.
things like
Yeah.
that. You just did a recent one about ESP32 and controlling a car over
Yeah.
CAN bus. What's your general interest in automotive?
So this topic kind of opened up to me when I was in France in 2011, 2012. I was there to get my master's degree, and as part of that study program, we had to do an internship with a company in the field of electronics. And at that point, I went with Freescale, and I was assigned to their analog and mixed signal and power division. And they generally deal with automotive in that Freescale division.
I was gonna say we should say Freescale rest in peace. Now NXP.
Yeah, now NXP.
Yeah.
Yeah, and during my internship at Freescale, I got to work at this really cool IC that they were developing.
Uh huh.
It was supposed to be the next generation engine control unit, so like the CPU inside an engine control unit. And as you know, across all industries, everyone tries to increase their profit margin, and to do that for an engine control unit, you basically need to integrate as much as possible into a chip and avoid populating that stuff
Yep.
as
Yeah.
external on a PCB.
Right. Which these days would probably make you seem, if assuming you could get the ECU chip, it would make you seem very smart because you wouldn't have all of the other chips that you would need to buy and couldn't get in the automotive space.
Yeah, that would probably be a good idea these days. Yeah, so that was like my first incursion into like the automotive electronics side of things,
Mm.
and I thought I really liked it. I mean, there was so much stuff that I didn't know it worked the way it did, and kind of
Any examples of that?
like this stuff that I worked on, this chip, like they
Hmm.
integrated so much stuff inside a chip, like both analog and digital. Like they used to need all kinds of these external filters, like no more.
Mm-hmm.
We will put
Yeah.
them all inside the chip. And on top of that, we'll put multiple values and we'll add this like selection matrix, and you can control and
Mm.
enable all of those filters digitally. And all of a sudden, you have all of these new capabilities that enable so much more for that ECU.
Got it. And I mean, when you're looking at an ECU as well, like I guess my inclination is to think that it's just kind of like maybe a CAN bus or two and a LIN bus or two, and then that's the main interface to it. But it seems like you're talking more like GPIO and like direct interfacing there.
Yeah, because I guess that can vary from manufacturer to manufacturer, but the ones I've seen, like they have like a bunch of sensors that tie in directly to the ECU, because the ECU is the one taking decisions on how to run the engine, and running an
Mm.
engine is based on a lot of sensor data, sensors that are spread around the engine.
Ah, I see. So it would be too much overhead time to have it go through a secondary processing, or you wouldn't want to have it on a bus where it might be time multiplexing, that sort of
Yeah,
thing.
I would guess so. Like
Yeah.
many important sensors tie in directly to the ECU box.
Got it. Okay. Yeah, and I guess the other thing too is that like I get a little confused about the term ECU because I thought that other processors in cars are sometimes called ECUs even though they're not directly controlling the ECU or the engine. Is that correct or incorrect?
From my side of things, the way I see things and the people I've worked with, we were only calling ECU like the control that deals with the engine.
Got it. Okay. All right. So then that makes more sense then too. I mean, so then what is the relative spec? I mean, obviously this is 2011, 2012, you said. So like,
Yeah,
but what is the relative spec of a processor in that space? Is it like a Cortex M0, Cortex M4, Cortex A something?
I can tell that it was all custom. Like
Oh, interesting. Okay.
it was all custom, and I can tell you that due to wanting to get the most out of it, it was all coded in assembly, so it was running assembly
Oh,
code.
wow. Oh, wow. Okay.
But it doesn't have to do like very complicated stuff. It just
Yeah.
needs to take very fast decisions based
Mm,
on sensor data.
got it. So like pipelining, if this sensor goes up, then do this other action on the other side on a GPIO, something like that.
Yeah, and at the
Yeah.
same time control like these high current outputs that sometimes drive the injectors that inject
Uh,
fuel into the engine.
uh-huh.
At the
Okay.
same time, you all of this operation needs to happen over a very wide range of temperatures and like supply voltages, which complicates things.
Mm-hmm. Yeah. Yep. Yep. Yep.
Yeah, but
That's
we were talking about how this opened up my interest for the automotive electronics, and you can
Hmm.
kind of see how there's all sorts of complicated and interesting stuff happening in the automotive electronics, and I like it. And so I kind of continued after that, and started thinking about these small projects that I could design in my lab and play with automotive electronics. And one of
Mm.
them is the CAN light. And this is a board that I designed, probably started designing that a year ago. And what I wanted to do is to kind of interface with some of the electronics on board of my car. So I wanted to kind of read some information from the CAN bus and maybe put something on the CAN bus that would trigger a reaction in the system.
Hmm.
So I made this board which has an ESP32 on board. That is the processor of the board. Then I have a CAN transceiver for interfacing with the CAN network. The ESP32 does have a CAN interface, but it needs an external transceiver to switch the lines at the correct voltages.
Hmm.
And I also added a couple of automotive high side switches to this board. Now, automotive high side switches are like a MOSFET, just that it has some added intelligence. It has some added protection features. So you deal with it approximately the same way. You just switch a logic high or low to control it, but it does its own thing to protect it against transients, to protect it from over temperature, over current situations, and
Mm.
and that's really nice to have, because from this little board I can then turn on or off a small motor. I can control something on power to something that is hooked up to my car.
Mm.
I want to say that it also contains an automotive grade DC to DC converter for power, because you can't just go and use any DC to DC converter on one of these boards, because what might happen is there are a lot of transients on the like the 12-volt line on a typical car. So there is a high chance that a typical converter might fail at some point due to all of the stress that it encounters.
Mm. Yeah, that makes sense. Yeah, I mean, it is a rough environment, and the ESP32. What is that rated for in terms of temperature? Like, could you actually put this whole unit into a automotive rated environment,
No,
or is it
I
more
mean
like zero to
it's more like
40?
standard. It's more like
Yeah.
standard temperature range. So
Uh huh.
you wouldn't expect it to kind of work at those extreme temperatures. But then again, if it sits on the inside of the car, it's probably not subjected to those.
Right. Right.
Most of the times, it will not be subjected to those extreme temperatures.
Yeah. Yeah. I mean, and this seems like this is a great way for people to kind of start tinkering with their car, maybe not make a product out of it, but then they could get a better feel for what's going on and then harden it over time and stuff like that.
Yeah, I think it's an awesome little CAN hacking platform, because
Yeah. Yeah.
otherwise, what are you going to do? Are you going to grab like one of these big STM32 development
Right.
boards? And
Yeah.
yeah, that's going to take up a lot of space, and it's going to make your life harder if you just
That's
need
right.
a CAN interface and a beefy processor to run your code.
Yeah. Well, that's interesting. So obviously you talk to your users, the people that are buying these boards. What are they doing with it?
So they're doing lots of interesting stuff. Like one of the users emailed me some pictures, and he actually just grabbed the source files and spun a new board based on that design. And it's actually grabbing some useful information from the CAN bus, like speed of the vehicle, the temperature of various fluids, and it's showing them on this head-up display that he put up on his dashboard.
That's cool. Yeah. So a lot of people that are like tweaking and they
Yeah,
want to like
typically.
optimize their car
Yeah,
and driving and stuff like that. Mm.
yeah. There
Yeah.
might be
Yeah.
other interesting stuff. There might be some secret stuff. I don't know. People are not telling me everything.
That's right. That's right. Yeah, it's not sending back telemetry from the ESP32 to Florin's computer or anything like that. So
Yeah,
yeah, no, that's great. I mean, and I think having that connectivity to then as well. I mean, you might even be able to put it, under the hood, through the firewall without having to actually punch through the firewall of a car, and you could have some more connectivity,
yeah,
which is great.
yeah. You could adjust settings on the fly, and
Hmm.
just from a simple web page that you open up on your smartphone.
Hmm. Yeah. Yeah, and I mean isolation then as well, right? If this thing's, I mean, not that it would be floating to high voltage levels or anything like that, but I
Yeah,
guess maybe if it was in a EV or something, it could maybe float up, right?
it's always nice that you if you don't need to touch the hardware. Once you've installed it,
Yeah,
it's always
right.
nice if you don't need to get back in there and mess with the wiring.
Yeah, that's great. Well, that's great. I mean, and so then interfacing with CAN as well. We've had Machina folks on here many years ago, and they were doing some CAN bus stuff. I remember them talking about like you just kind of like can kind of, it's not encrypted. You just kind of push and pull readings off of there. It seems like
Yeah,
it's kind of the Wild West. You just have to like know what you're looking at and know what you're reading. Does that
yeah,
sound right?
yeah. So you do pick up everything that's on the bus, but knowing what every byte of data means, that's a whole nother story, because there is literally almost no standard. I mean, each manufacturer does have its own standards, but they're kind
Mm-hmm.
of secret about it, and they're
Yeah,
not releasing it to the public.
got
So
it.
you kind of do a lot of reverse engineering to figure out what's going on the bus and what each frame ID points to.
Yeah.
And sometimes manufacturer, they go on top of the standard CAN bus spec, and if they want to transmit more data, they wouldn't be able because of the CAN bus, framing and how it's organized. But what they do is they sometimes split their data across multiple CAN transmissions, and
Mm.
they kind of add their own protocol on top of CAN bus to be able to reconstruct all of that data. And you're really in trouble if you're trying to decode something like that.
Yeah. Yeah, you're like, this doesn't make any sense. You got to glue it back together. That's really weird. So like in terms of like the CAN protocol and stuff like that then too, is it just if the bus is available, it's just like you can kind of take control, or are there priority levels? How does that kind of all get coordinated?
So I'm hardly an expert on this field, but
More expert than I am. Here's
yeah,
yes, that's all that matters here.
here's how it works. It's based on the way the CAN bus is designed is that it's based on the priority of the ID that you're sending.
Okay.
So the lower the ID, the higher the priority, and that message is going to be processed first.
Okay.
And what happens in a typical automotive CAN bus network, like the most important stuff that's related to the engine, the braking, the critical stuff, that has the lowest IDs on the network. So those
Braking's only if you don't want to
messages.
go fast, man. I mean, come on.
Yeah,
True,
it
true,
depends.
true racing mindset is, braking is last.
I get that. Priorities can vary from from one man to another.
Uh-huh. Yeah. And is that like settable then as well?
Sorry, I didn't get that.
Is that settable? Like can you set what priority is what? Like, so if I open up the hood and started tinkering with the brake system, is there like a dip switch in there so I could switch priority from like a 6 to a 7?
No, so that's based on a fixed ID that that particular module has, or
Okay.
that particular sensor has. So, for example, I'm just pulling numbers here that might not be
Sure,
real
sure.
addresses, but let's say some hex address, which is 110, has a higher priority than a higher number.
Yeah. Got it. Yeah, I've done something like this on an RS-45 bus where it was like lowest wins because it was actually like it was like XORing the addresses or something like that. But it was
Yeah,
like going through all the different addresses, and basically once it hit the bit, once it hit like a one in a binary number, it's like, okay, now I know I can talk to this thing.
yeah. So Canvas is doing a similar thing, and I don't know all of the details. But if two devices want to talk at the same time, because of the way the network is constructed, the lower ID is always going to have priority.
Mm,
So
got it.
he's going to talk first,
Got it. Hmm. That sounds like kind of hectic.
and yet is used for the most important stuff.
That's right. Yeah. Yeah. Well, I'm gonna start riding a bike more, I think.
Yeah, I think there's really a lot of backup built into these protocols. So there are a lot of checksums and a lot of opposing values that need to match for the most important stuff for that computer to actually consider that information good and well
Yeah.
received.
Yeah, I guess I'm thinking about it in terms of like if I was just grabbing modules off the shelf and like, okay, this brake module, this engine module, whatever, 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 and gluing it all together. But in reality, the car maker knows they can decode all the packets. They know what's going on when they piece it all together.
Yeah.
And then we're just kind of reading it if we want to peek into their world, right?
Yeah, and to complicate things, typically on a car, you'll also find a CAN gateway because
Mm,
on a car there's usually more than one CAN networks. So all of these different CAN buses tie in to a CAN gateway, and the CAN gateway has to like interface between all of these buses and let through only some of the messages from one bus to another.
got it. So it's like a translation system almost.
Yeah, almost. Like some of
Yeah.
the messages from the engine we want to propagate down to the multimedia system so we can show like RPM and speed on
Yeah.
the digital screen, but we don't need to send all of the data from the engine CAN bus to the multimedia CAN bus. So all of this
Mm.
filtering happens.
Yeah, you don't need like the temperature of the cooling fluid or something like that unless you're
Yeah,
doing some really crazy stuff.
yeah. Yeah,
That's
and
great.
on top of that, to complicate things even more with more recent cars, they have also started encrypting some of the stuff. So, like modules will first try to authenticate with the ECU to make sure that they belong to that car and they have not been like harvested from another car and just installed on this car. So they use some encrypted keys to authenticate, and only after authentication is successful, they start talking on the CAN bus.
I see.
So it's even more complicated with newer cars.
Huh. So then what are you messing with your car? I mean, what's your interest in this?
Yeah, so what I wanted to do is it turns out you can kind of display your own information on the small display you have inside your cluster with the speedo. And to do that, you basically have to first capture the information that you want shown there from the canvas. And then you'd have to send it in a certain way to the cluster computer, such as to create this custom menu on that small LCD and show your own data. So they have actually built in this functionality into the cluster firmware because there are some modules on a car that would natively want to do this. I wanted to build this board to replicate this functionality and show data that wouldn't otherwise be visible on that small LCD screen.
I see. And you're monitoring like, are you doing some mods and stuff like that to your car? Is that why?
I'm not big fan of doing mods to my car, but it's just the electronic side which is very interesting, and just reaching that milestone of finally being able to do that, it just means a lot to me.
Yeah, yeah. That's great. I mean, and I guess we've implied here, but you are selling these as well. I mean, when you can source the components, you just made a video about having trouble sourcing. But what is the experience like selling Tindy and equivalent?
So the selling side of things on Tindy is pretty straightforward. Like they take care of everything, and that's pretty easy. I mean, I've only been on the platform for starting this year, so I don't have a lot of experience, but it's been going great for me. Now the actual building of the electronics during these times,
Yeah.
that's a whole different story.
Uh huh.
So, for example, I am already at revision D for the CAN light board,
Yep.
just because I need to constantly switch some parts and find new ones because
Mm-hmm.
the old ones are not available anymore.
Yeah.
And they have those delivery dates of, I don't know, like next year or 2 years ahead. And I can't wait that long. And the people on my Tindy store can't wait that long,
That's right. Yeah. Oh my gosh. Yeah, it's a shit show out there for sure. It's especially, I mean, well, especially automotive, right? I mean, like
especially.
that.
Yeah.
Yeah, more than
It,
anything else, you're
it's
just kind of scraping the bottom of the barrel.
it's probably the worst kind of business that you can be in at the hobby level that I am,
Uh-huh.
right? It's
Yeah.
worse for the big auto manufacturers, but if you think about it, it's going to be much worse for the little fish like
Hmm.
myself.
Yeah. Well, it's nice that you offer the files. You're like, if you want to try and build this yourself, good luck.
Yeah, and I've had the biggest trouble, finding the high side switches, but some people don't need those. They just want to hack their CAN
Yeah.
bus and they
Yep.
just don't need to switch anything. So I have the option of ordering the board without those high side switches
Mm,
just in case I can't get them anymore.
that's good. Yeah. Yeah. It's crazy times. I mean, so do you have any tricks you'd like to share about sourcing components? Anything? Are you do you
Like one trick which might be too late to apply for most people is to keep a good stash of the components that
right. Time machine. That's
yeah.
called.
Yeah, so that saved me, like with a recent project that I was doing for a client on my consulting side of things. I just had a bunch of the parts that we needed for the prototypes that I was building for this client. I had them in my own stash of parts
Hmm.
because
Yep.
I do have a lot of parts stashed in, these IKEA plastic
Yep.
bins in
Yep.
in my lab. And sometimes that really helps because I just went to my boxes and found the STM32s that he needed. I had about 10 of those left from a previous project, so I was able to build his 10 prototypes, and everyone was happy.
I mean, what you really should have done is you should have sold those STM32s on the open market and just retired. You could have just been, living
skip,
large by the
yeah,
seashore.
yeah, skip the hard work of building the hardware.
That's right. Yeah, yeah. I mean, how is it on the consulting side of things?
Well, it's hard. Like,
Mm,
I mean, recently I've had clients that are not necessarily building stuff in the hundreds of thousands or even thousands of pieces. So it's mostly they're building stuff in the tens of pieces. So
yeah,
in quantities. So that's much easier, but still you have some difficulties. Like you try to work your way around the design phase, such as to have some backup plan. Like
hmm,
is this IC really the only one that we could get it? Because if this becomes hard to get, then we're going to be unable to build these
that's
boards.
right. Yeah, you can have a bad time.
Yeah. So I try to do my best to find and select some components that have some that can be replaced at some point, maybe with a little effort, just by switching to a different footprint or adjusting some of the IO. But I try to keep in the back of my mind that I need to find a part that should and be able to be replaced at some point with a different part.
Hmm. Yeah. We're back with Mauser Electronics and talking with Paul Galata, Senior Technology Specialist, who will be talking about the new section on the Mauser Electronics resource page about immersive technology and how it will change workflows in the future. I asked Paul what he saw as the most impactful elements of immersive technology.
Well, I think there's a couple things. We're going to be doing designs in a whole new way. One of the exciting things, I think, from an engineer, what do we care about it, is collaboration is going to change immensely. With the internet, we all communicate and share our ideas, but we do that kind of with pieces of paper, right? We've moved, as you've seen with all this COVID now, that everybody's doing Zoom and communicating on that, but it's still a kind of a two-dimensional thing. What, though, if I could step right now, instead of just seeing you on a screen and actually feel that you and I are present, that it feels like I'm just 3 feet away from you and you and I are having kind of a conversation where you can actually see me having my cup of coffee and you feel like that I'm present and it sounds that way and you can move around in a space with me and maybe we can jointly experience things together.
I asked Paul about some of the technologies that will allow us to feel more present across the web.
I think, first of all, it's interfaces that are providing new accessibility. So, one of the ways, for example, is tactile connection. So, you've probably seen people with gloves and the ability to take a type of glove that's on them, manipulate this glove, and then move digital objects in space. So that's coming. This whole explosion that's happened with spatial computing, leaders such as NVIDIA, with what they're doing in the computational space and other world-class leading semiconductors are taking the ability to manipulate the math and the processing in 3 dimensions and do the calculations so that this whole three-dimensional aspect of what's going on and being able to both look around in a 360-degree world and go up, down, left, right, inside, outside in that that type of stuff. It's just happening automatically.
So, what are some real world examples of this experience, and how does it impact consumers?
My daughter and her husband are looking for a home. Well, you know what they're doing? They're virtually touring all that type of stuff. Again, that's a virtual tour where you can look 360. They're doing it on a two-dimensional screen. But the next step is to be able to take that and, if you will, put on a headset, put on some, tactile gloves, and you will be in the house. You won't just be looking at it two-dimensionally on a computer screen. You'll be like you're there, thereby making it so that it's almost like you went to the house itself. You can walk through and manipulate, your space and position in this domain.
To learn more about immersive technology and how it might impact your workflow, check out the amphour.com/immersive, which will take you to the Mouser Electronics Immersive Technology page. And now back to the show. How are people finding you for your consulting work?
So I think my YouTube channel is the main gateway into finding clients for the consulting work. People will typically search online for a particular topic that they're interested in for building stuff, and sometimes they end up on my videos, where I might be talking about that subject, and they see, hey, this guy is talking about exactly what I want built.
Yeah, that's nice too, because then they come to you like, hey, can you build me a ESP32 with a CAN bus? It's like, oh, actually, yes, I can.
Yeah.
Yeah, I mean, it's interesting. I mean, so then as someone, so you have 33,000 YouTube subscribers,
Something like that.
Not small, not huge, but definitely a good size. Seems like a good community. Would you recommend people start a YouTube channel just for kind of showcasing their services, or is it not really worth it just for that?
I think it's an excellent idea. I mean,
Okay.
it's a little more difficult these days to, kind of get noticed on YouTube. YouTube is so big these days, and it's a bit more difficult to get noticed. But YouTube, from a search engine perspective, it's like the second biggest search engine that people use. So that has to count for something. You know that at some point people are going to be searching through YouTube stuff, and they are going to be ending up on your videos.
Yeah. Yep. Yeah, that's great. Yeah, and I think especially if people are, showcasing their own projects, right? If they want to like start consulting, I think it makes sense, or just start doing electronics for a living broadly, even if they're not consulting. Maybe they want to go work for a company. It's like if you're showcasing your own projects, you want to like show off what you've been working on. You're excited about electronics. It just seems like that's a good venue to do that sort of thing. It's just a lot of people are not wanting to be in front of the camera. Obviously, I think you're very natural in front of the camera, so that's a good start.
I mean, it's something that you work on. It's not going to be easy, or your first video is probably not going to be so great, but it's something that you work on and get better with over time. So that's not a reason not to start.
Yeah, I think that's right. Yeah, you just gotta not care at the beginning.
Yeah, and it's also good to not care along the way, because there's going to be some ugly comments that you receive.
Oh well, yeah.
But it's part of the course, and you just have to move on.
Yep, that's great. Yeah, I mean, over time as well, I'd imagine that you build out your lab. I mean, you do a lot of videos about your lab. You build out that sort of thing over time. It just kind of seems like a gradual build up.
Yeah, I mean, I've switched to like 3 different labs since I've started the YouTube channel in 2015. So you kind of build and improve with each new one. The latest one is the greatest in my opinion. I have this great new Workbench. I did a video on the Workbench build. I built it from aluminum profiles instead of the usual, wood timber frame construction.
Yeah, I saw that. That was a good one. And you did you'd be able to design. It was like an online design tool. Is that right?
Yeah, I mean, I did it in Fusion 360.
Got it.
It's just I just built it how I imagined it, and then there are these online shops where you order your aluminum profiles already cut to size.
That's what I was thinking. Yeah, that piece is what I was thinking about. Yep.
Yeah, and that's super helpful. I mean, if you can get those aluminum profiles cut to length, then the only thing that you have left to do is to assemble it with screws and nuts.
Mm-hmm.
So
I'm just staring at your cover image for this video. It's like do you increase the size of your head or something? It's very like uncanny valley style. It's like
yeah, I thought that would be an interesting thumbnail.
yeah. It looks like like anime almost, you know?
Yeah. Yeah, I mean, you have to get creative with these thumbnails, and I don't do
Yeah.
it all the time, but when I do it, you notice it
You go
in
all the
the
way.
yeah, people just click that thumbnail more than they would
Silly.
otherwise.
Yeah. Yeah, that's the trade-off, I suppose, of the YouTube side of things.
Yeah.
Oh, that's great. So, I mean, so on the consulting side and generally, like the stuff you're making videos about that you are interested in, like what would be, what's your sweet spot, I suppose, on the consulting side? Is it STM32 kind of stuff? Is it ESP32? Is it automotive sensors? What are you hoping to do in general?
I haven't done any specific, automotive stuff for my
Mm,
consulting side, because that's typically what companies that build stuff that actually goes into cars, they tend to deal with bigger
mm,
consulting companies, not a one man show like I'm running.
mm-hmm.
So I guess that's one of the reasons which I haven't built any projects on that side of things professionally. But I do build a lot of IoT stuff on my consulting business. Have a lot of clients that would like to build, in general, small stuff that's wirelessly connected and somehow contains some sensors, somehow transmits data over the air.
Mm. Yeah, that's great. I have said many times before. I think my my paycheck for the next 10 years will be things that people want to hook to the internet. Like a lot of
Yep.
industrial things that they're just like, yeah, I just want, I have this thing, I want it to work, or it already works. I want to make it work and talk to the internet. It's like,
Yeah.
okay, well, that's not trivial, but we can make it do it.
I think that takes a good share of the market in this field. And kind of specifically, I think it tailors best to this type of business, this type of consulting
Hmm.
business, where you would hire one or two engineers to work on that project and design it for you.
Yeah. Yeah, I think that's right. I think the scaling piece, especially, it depends who they come through with. I've had people come through as like software companies, and then they're like, yeah, we just need the hardware at the end piece. And it's like, oh, okay, yeah, I can do that. And then I've had other people who are like, I need you to do all of it, and then I have to usually pull in some software people and that sort of thing. And then it's kind of a different style of thing where it's almost like standing up an entire system for them versus kind of slotting into the system they already have.
Yeah, that can be nice. For example, I have my new lab in an office building, and there are some software coding guys here which are really good, and I
Hmm.
did work with them on a past project with a client of mine, and it was a really good cooperation, being so close with them. And I
Yeah,
dealt with the hardware side of things, they did the software side of things for the client.
yeah, that's great. That's
It's
great.
nice to
And
have these kind of people that you can collaborate with on such projects, because you deliver more value in the end to the customer.
yeah, it's almost like you're building out like a little ad hoc team, and then kind of you scatter afterwards. It's
Yeah.
yeah, it's good to have those kind of partnerships and stuff. Are you where are you mostly like in your area? Like where are customers located? Are they kind of all over the place?
Most of the times international customers.
Oh yeah, okay.
Like I have few customers from here, from Romania,
Hmm. Yeah,
but most of the times it's like United States, Germany, United Kingdom.
yeah, that's great. Yeah, international consultant of mystery.
I know it's nice to meet all of these people. It's nice to work on such a variety of projects.
Mm,
Sometimes you get to work with other teams, because sometimes you're just brought on to help on a particular project on which an existing team is already working on.
mm-hmm. Yeah. can I try and convince you to go to Embedded World in March? Maybe we can meet up. I'm going to be there.
I was actually thinking about that because I've heard you mention that in a previous Ampower.
Uh-huh.
So I was actually thinking about that.
Doesn't look like a short trip from your part of the world, but
yeah. So
yay.
the last time I wanted to go to a similar meetup was to Hackaday Belgrade. I think
Yeah.
I even got plane tickets and booked some accommodation there, but in the end it got canceled. So
Oh, it was the 2021.
yeah.
I've heard rumor that will come back, so that's good.
Yeah, I'm kind of eager to leave the country and go to one of these meetups.
Yeah, the same. Yeah, it's been a little too long since I've had like a true nerd out session, in person, and
Yeah.
it's just not the same on online.
Yeah, I think there's a good chance I'll be there.
Okay, great. We'll coordinate after. We'll talk about that. But if other people are going too, then we could all meet up, in a safe way, of course. Assuming that there's no flare ups of COVID like usual. I long for the old days.
We have to adapt.
Yeah. So you also are a ham. So I was watching your video about the repeater you did
Yeah.
about a month ago or so. What drove that interest?
So actually, I wanted to get my ham license even before COVID, and here in Romania, the exam, I mean, it's not super difficult, but it's not as easy as it is in other places. Like you still have to pass this theory exam where they put you through all of these different subjects and kind of need to know them all to pass the exam. And I studied for the exam, then COVID came, then the exams got canceled or delayed. And then I was reluctant to go to the next exam because of COVID. So it kind of took me 2 years until I got back on track and finally managed to go and take this exam for the ham operator license.
Nice.
And I got it. My call sign is Yankee Oscar 4 Victor Lima Tango. That is in call sign language. I'm happily using that language, even though it's not necessary.
You said Yankee Oscar 4 Lima Tango, is that right?
Victor Lima Tango. It's like an abbreviation from Voltlog.
Oh, nice.
Yeah, I'm probably too excited for this.
That's great. Oh, cool. Well, and how far afield is it taking you? Are you making contacts far and wide?
No, no. For once, because of lack of gear, and I'm probably also not really into that thing, making long range contacts. I know it's a thing in the ham operator world, but it's not what attracts me. I just have a small Baofeng radio, and I just use it to connect to one of these repeater networks that the awesome guys here in Romania built. It's called Rolling. And so what they did is they built this network of repeaters, so you can connect locally short range to one of these repeaters over analog, and then it just goes through the internet into this national network.
That's awesome. Yeah, I mean it is interesting in like the days of like the internet too. Obviously, you and I are talking over very very large distances, and we're near perfect quality. But there's still something about it of like doing that through a handheld. Basically, you have just it's for the interest of doing the ham radio side of things. So
yeah. So as you were saying, I built one of these small repeaters myself because for once you can connect to one of these, let's call them higher power repeaters that some people build and maintain. But at some point, that repeater is probably going to be offline, or you're probably going to be going off coverage. And I built this portable repeater unit that just uses a small single board computer, an Orange Pi.
Yep.
and it uses one of these walkie-talkie modules. I believe the part number is SA818. So it's a module the size of an ESP32 module that basically has all of the walkie-talkie functionality built into it.
Yeah. Like, yeah, TXRX, it does the keying for you, all
Yeah,
that kind of thing, right? It's just like simple GPI inputs and a single antenna.
yeah, and half a
Yeah.
watt or up to 1 watt of output power.
Yeah.
So you have this portable node that you can connect to like a wireless hotspot that you generate from your smartphone, and it
Uh-huh.
goes through the internet, and you're onto the network from like any place where you get cell coverage.
Yeah. That's pretty awesome. I mean, like that is really fun for, like, if you're doing events or similar kind of things. It's just yeah,
Definitely, yeah,
it's a lot of fun.
and
It's
it can hold more users, like not just for
yeah, true.
yourself.
That's true. That's true. Huh. Yeah, I just finished the Surely You're Joking, Mr. Feynman, and there's an anecdote in there where he's like he's in Brazil and he's trying to get data from Caltech. He was on sabbatical in Brazil, and he was using these long range contacts to contact Caltech, like Pasadena, California, and it's like, oh, that sounds terrible. Like
Yeah.
that's when it was really really important that you had that sort of thing, but now it's just like, okay, well, let's send an email or a
Nobody thinks about
call.
it anymore. Yeah,
Exactly.
distance
Yeah.
is not a problem anymore.
Yeah. It's- but now it's just for fun, and I mean that's a super cool module. So then, in terms of like the interfacing, was it tough to actually getting that walkie-talkie module to talk to the Pi?
No, because I have this kind of mindset when I'm building these projects, and this is partly due to the fact that I present them on YouTube and I
Hmm.
do a video each week. So I kind of don't have a lot of time at my disposal to
Mm.
build these projects and document them and present them on a YouTube video.
Hmm.
So usually that's not enough time to build both hardware and software. That's usually just enough to build hardware and maybe just a little bit of software.
Got it. Yeah.
Just the time frame is too short. And what I like to do is I try to build projects where I can do a lot of the hardware side and very little of the software side. And
Yeah.
this is one of those examples where the software side of things was already done for me.
Yeah. Because it's on the Pi, and there's like a software stack on that
Yeah,
Linux board and stuff.
yeah, they just built this Linux image that you just load onto an SD card, and it already has all of the required scripts and software pre-installed. It's just a small config file that you need to adjust to your own needs, and then you're up and running.
Hmm. Yeah. Florin, when are we gonna want to get better at software? This is the thing I keep struggling with. Like, yeah, I don't know.
I don't think there's enough pressure these days. Uh, like I don't know, 10, 15 years ago, maybe there was a lot more pressure and you really had to do it yourself. But these days,
Yeah,
I
yeah.
take on a new project, and even if it needs a large chunk of software to be written with, I can just collaborate with a programming guy that does all of the programming for me. I deal with the hardware, he deals with the software, and we're both happy at the end of the day.
Yeah, yeah. See, now this is another thing where the internet, it just ruined things. It ruined the long range contacts. It ruined the collaboration. It used to be more self sufficient. I guess, I don't know. Yeah,
Yeah,
we just get to play around with the stuff that we really like, the hardware.
yeah, I have a lot of examples like this in my recent projects. The other one is the valve controller based on ESP32.
Hmm.
That one just was designed to run this open source firmware, which is called Tasmota, and it's this MQTT based platform that runs on ESP8266 and on ESP32s, and
Hmm.
it's just great for building automation type stuff because it has drivers for most of the stuff that you would normally connect to an ESP32, and you
Mm.
just load that firmware image and you're good to go. You just need to configure some GPIO and everything just runs.
Huh. And what kind of valves are we talking about here?
I'm talking about these thermostat valves for a floor heating system.
Oh, cool. Okay, like a radiative, like style heating.
Yeah, yeah, they are electric valves. They are typically based on this wax cartridge, and they have this small resistive heater. So when you apply power, it starts heating up, and it takes about 2 minutes for the wax inside that cartridge to completely expand and push this pin to actuate the valve.
Huh. It's wax based? That's really weird.
I don't quote me on that. It's probably not the most accurate piece of information. I'm just guessing here because other types of similar valves are built
Yeah.
on wax cartridges.
Well, that's I mean, that's really cool if it is, though. I mean, like I just
It's
feel like that would wear out, but I guess
No, it's
if it
the
works, it
most
works.
reliable way. It turns out
Huh.
it's the most reliable way of
Yeah.
controlling these valves. Because the
Huh.
other way would be to have some mechanical, gears, or
Yeah.
you know,
Right. Right. Right.
and that's a lot more parts that have to move, and that's a lot more stuff that could fail in the long term.
Yeah. Right. I was worried about that sort of. And so this is like resistive heating, or is this like the
Yep,
fluid
resistive.
style?
It's
Oh, okay.
just a resistive component in there that heats up something. Could be wax, could be another type of fluid that just
Mm-hmm.
expands with temperature
Yeah.
inside the cartridge. And through the action of that fluid expanding, it just pushes a pin that actuates a thermostat valve.
Hmm. That's super cool. Yeah. And so this is what's keeping your lab warm, or your home, or what do you use it for?
Yeah, I use it in my home because I recently installed one of these floor heating systems,
Huh.
and you don't really need this level of automation. But if you're like an
Well,
electronics engineer, why
yeah.
wouldn't you do it?
I mean, what do we really need though in our lives in that way?
Yeah, I mean, you can go without it, but it's
Uh,
fun to build, and
yeah, totally.
and you can then get statistics. And what engineer
Uh-huh.
doesn't love seeing nice
That's right.
statistics and graphs in his home automation project?
Yeah, yeah.
I love that stuff.
Yeah, that's great. That's great. I always think when yeah, like they also have those kind where they have like liquid going through piping in the floor. That's what I thought it was at first. You're
Well,
talking about.
yeah, it's based on liquid.
It's based on
So
liquid.
there are
Oh.
pipes laying in the floor.
Oh, what is
And
that? Okay. All right. All right.
yeah, and
Okay. I thought it was resistive, like a wire in the floor, like
no,
a
so
heating element.
there's actually liquid going into those pipes.
Uh-huh.
And because you have different circuits going to different rooms or different sides of
Yeah.
the room,
Okay. Yeah.
you want to be able to control those circuits individually. So you have one
Mm.
of these valves on each of the circuits so that you could turn it on or off based on the heat requirements for that specific room.
Yeah. That's awesome. Yeah, I always wanted something like that. I always just felt like that idea of like having like a nice toasty warm floor would be like super nice, and like to be able to dial it in so that when you're not in a room it turns off, whatever. And my answer instead was to move south.
Yeah, I heard about that in your recent Ampar talks, that you moved
Yeah.
south and the winter is much nicer now. You
Oh,
go out for walks.
that's right. Yep. Yeah. It was 70 the other day, or well, it was 22°C the other day. It was great. It was, yeah. It's I'm quite wimpy now though. I get cold. I get cold much easier. So that's the downside. I'll be traveling to see family for the Thanksgiving holiday here, and I'm a little worried. I'm a little worried about how I'll handle it.
Probably gonna have to pack some warm clothes.
That's right. Yeah. Yeah. Does this floor heater, does it work for like heating clothing?
No, but I do think they sell something that works off a power bank or something like
They do. Yeah.
that.
Yeah. They do. I saw they actually have it at like the home repair store here. They sell them there, and
Yeah.
I had heard about it like on Banggood as well. You could get like resistive heating elements for your clothing.
But I think you've lived in the cold side for a lot of years, so there should be
Just
something left in you.
you'd think so. You'd think. Yeah. I hope so. I hope so. Well, I'll find out soon. By the time this episode's published, I'm sure I'll have some feedback.
Well, I am the kind of person that much prefers the cold over the warm,
Oh, interesting.
and I'm
Yeah.
talking about the extremes here. I would rather stay in extreme cold than extreme hot weather.
Huh. What are the ranges of temperatures in your part of the world?
It depends. I mean, especially in the last few years, we've had some change of things in
Mm.
what the weather is like, and
Mm.
I think anyone all over the world can say the same thing. It's not the
Hmm.
same as it used to be,
Yeah, I agree. Yep.
but typically in the winter, right in December to January, right here where I live, we can get minus 10 degrees in the night. Celsius.
Yep.
And it can go, positive 5 degrees over the day if it's nice and sunny. But during the summers, if it's a very hot summer, we can easily get 35 degrees Celsius, even higher than that.
Yeah. Okay. So that's pretty big swings.
Yeah.
But I mean, you are right near the water too, so that helps. I'm sure
that helps. Yeah, definitely helps.
I mean, if nothing else, then to just be able to run and jump in the water,
Yeah, that definitely helps.
Yeah, that's great. So we are approaching the end of the show, but also approaching the holidays. I wanted to point out you have a really fun video about gifts for electrical engineers. I thought you do a lot of mailbag stuff, but I think this is really useful for people that are looking to tell their family what to get them for the holidays.
I mean, I look at my family members and they really struggle when they're trying to get me a present.
Yeah. Like, what? You want what? For what?
Yeah. And they kind of they've gotten used to it, and they kind of feel the stress when the holidays come up, because they really need to find something that's going to be appreciated, and they go through this stress. And I was thinking, hey, there must be other people out there going through the same trouble. And I like doing these videos every year, and I typically like showing stuff that I have owned and have tested in these videos. That's always a positive thing when I can say about a particular tool that I have used it for the past year or even more, and I find it useful.
Yeah. So can we get, out of the 10 that are in this list, can we get maybe a preview of 2 of them so that people can hear some ideas, price range and what they are?
Yep. I'll give you a very cheap one that I think it's really useful, and every electronics engineer that builds prototypes and tinkers with electronics should have. And that is the aluminum syringe plunger. So, as when you typically order these flux or solder paste syringes, they tend to come either without a plunger or with a very skinny plastic one. So there is this aluminum designed one that fits over a standard solder paste or flux syringe. And so it's reusable. When that syringe is done, you can just install it on the next syringe. And it just feels good when you're dispensing solder paste or flux from a syringe to use one of these. They're sometimes called boosters on AliExpress, and they're really cheap. They're like $4 or $5 a piece.
And is it just because it doesn't push any harder, right? But I guess it won't snap if you push really hard. But
yeah, it just feels like something solid as opposed to a flimsy plastic plunger that you take from a standard syringe.
Okay, that's a good one. I like that.
And on the more expensive side of things, I can talk about the Unity waveform generator, which I got this year.
Is that the one that you said everybody should have, must have this one?
Yeah, it's that one. Because I believe it's just over $100 or something like that shipped.
Yeah. Yep.
And it's a really cool waveform generator. I mean, if you're an advanced user, it's probably not for you. But if you're just starting out with electronics, or if you want to run your own experiments, or if you don't need anything high frequency or very, very clean signal, I think it can work just great for you. For experimenting, just for educational purposes, I think it's great.
Yeah. This is looks like it's like a tiny bench instrument. Just looking at the size of the ports and stuff.
Very small and compact. It's powered by a USB line. So you could very easily turn it into a portable unit. You can power it from a power bank just as easily.
Yeah. And do you think this has benefits over, I guess this is a bench instrument, over like a USB based instrument? I was talking about the Analog Discovery 2 last episode, and it seems like it's about the same range and stuff. I'm guessing the chipset's probably pretty similar.
I haven't used the Analog Discovery. I know about its functionality. I don't know about its specs or cost, but if it's in the same price range, then it probably depends on how your preferred way of working is.
No, it's like almost double or triple. So,
but it also adds a lot more functionality, I would guess.
Yeah. Okay. Yeah, this is good. This is a good bench one for sure. It's very cute and compact. I mean, it definitely has the right form factor that's pretty fun. So
I mean, some people prefer to work standalone with Workbench type instruments. Some people prefer to work in front of a computer. So it also depends on how you prefer to work.
Yeah, I think that's right. Yeah, a lot of people they just say, no, I need to have a screen. I need to have knobs I could turn, buttons I can push, that sort of thing. So I think this is a nice interface for that sort of thing.
Yeah, so these would be like my cheap and a bit more expensive selection from that video that I would recommend as gifts for engineers for holiday season.
Yeah, and I think too is like if you're gonna get stuff off, like the waveform generators off Banggood, and it's like you got to probably get the order in now to get it in time for the holidays as well.
Yeah.
So
I've been hearing that it's especially difficult this year with the the whole postal and logistics systems worldwide. We're going through some tough times.
Yeah. Yes. Buy your gifts early, folks, or else you're gonna have to shop in person. Good Lord. Oh man. Well, Florin, I would highly recommend people check the rest of your videos out. I enjoy every single one of them. You are a must-watch channel on my YouTube subscription, so please keep making great videos. I really like the stuff you're making.
Thank you so much, Chris. It means a lot to hear it from you because you talk to a lot of people.
Yeah, well, I do talk to a lot of people, but this is you're making the kind of content I like, including KiCad videos. So keep that up too.
Yeah.
Where can people find you online generally?
So people can find me on youtube.com/Voltlog. I mainly publish YouTube videos once a week, but I'm also on twitter.com/Voltlog. I tweet once in a while.
Great. And you have a Tindy store as well.
I also have a Tindy store. Just search for Voltlog on tindy.com and you'll find some of the products showcased on my YouTube videos. Some of them can be purchased from my Tindy store.
Awesome. Well, thanks for joining me today, Florin. I really enjoyed talking to you.
It was a pleasure to talk to you, Chris. Thank you for having me on the show.